Hello everyone, welcome back to our channel. Today we're going to embark on an exciting journey into the world of recursion. But before we dive in, let's understand what recursion is all about. The definition of recursion goes: the repeated application of a recursive procedure or definition. Simply put, recursion is like using a step-by-step instruction that keeps repeating itself until it reaches a simple condition. Or you could say it is like using a recipe where the instructions tell you to repeat a certain step by following the same set of instructions again and again until you reach a point where you can't go any further. Let's dive into the theory. To skip to the coding part, you can move to the 5 minutes mark. Recursion is a fascinating concept in programming and mathematics. At its core, recursion is a technique where a function calls itself to solve a problem. It might sound a bit confusing at first, but don't worry, we'll break it down step by step. So, recursion is a powerful concept that allows solving complex problems by breaking them down into smaller, simpler sub-problems. And in C++, recursion is implemented using functions that call themselves. To understand recursion in C++, consider the following key points: a base case, a recursive case, and the terminating condition. Considering the base case, a recursive function must have a base case, which is a condition that stops the recursion. Is the simplest scenario where the function returns a known value without further recursion. Now here is the condition that ends the repetition by returning a value. It's the condition that determines when the recursion should stop. Also, in recursive algorithms, the base condition typically corresponds to the smallest or simplest input for which the solution is known without further recursion. The second point to consider. In the recursive case, the function calls itself with modified arguments to solve a smaller instance of the same problem. Each recursive call brings you closer to the base case. In the repetition, you've been breaking down the problem, and that's the stage where you repeat a function to resolve a problem. Finally, the terminating condition. Without a proper termination condition or base case, the recursion will continue indefinitely, leading to Stack Overflow errors. A terminating condition refers to any condition that causes the recursive process to stop. It can include not only the base condition, but also other conditions that may halt the recursion, such as reaching a certain depth limit, encountering an error condition, or exceeding a threshold. Termination conditions ensure that the recursion doesn't continue indefinitely, preventing stack overflow or infinite loops, as already discussed. For example, you might have a termination condition that checks for negative input values. If the number is less than 0, then return a -1. Another point to consider is the memory usage. Recursion consumes memory as each recursive call adds a new stack frame. It's crucial to manage memory efficiently to prevent stack overflow. Let's use a more precise example. Imagine you have a factory where each machine produces a part of a product. To assemble the entire product, you need to combine the parts from all these machines. Here's how recursion can be illustrated in this scenario. The base case. If a machine produces a part that cannot be further divided, it returns that part. This is basically a condition to say, stop repeating. Not to stop the code, but just the repetition. Now, the recursive case is, if a machine produces a part that can be further divided, it requests parts from other machines and combines them to produce the required parts. And now as we progress towards the base case, each machine keeps requesting parts from other machines until it receives parts that cannot be further divided. So To produce the final product, you start with the machines that directly produce parts without needing other machines' parts. And then you gradually combine parts until you assemble the entire machine. I think we should now code. We're technical people. Let's solve two recursive problems. Firstly, we'll calculate the factorial of a given number. And then secondly, we'll calculate the sum of elements in an array. Let's write the code for calculating the factorial of a given number. We will start off with building the main function. Prompt the user to enter the number they want to get the factorial of. And then output this number, but then remember, this factorial will be computed in the function. This function will be recursion, so let's call this function here. Because we have not declared the function, we need to make sure that just build our function here on the top. We could declare it here, but let's just build it. Might as well just build it. The name of the function should be the same as we called it in the main function. And now to build our base case. If the n is not a 0 or a 1, we return a 1. But otherwise, we reach the recursive case where we constantly repeat this function calling onto itself to find the factorial. Because remember, to find the factorial of a number, you say, for example, if you had a 5, the factorial of a number 5 is 5 times 4 times 3 times 2 times a 1. So basically, this is what it will be doing, reducing the number of the next multiplication we're going to get onto. And that base case, because when it gets to a 1, is the end. So we're saying the base case, this is where we're halting, the condition to halt the repetition, not the entire code. Return those numbers that we are wanting. I hope it's making sense. But just to further explain this, in this code we define the function called factorial to calculate the factorial of this number. The base case is when the n is a 0 or a 1. And then in the main function, we take input from the user and then we call that function factorial and we display the result. So this code basically demonstrates how recursion can be used to calculate the factorial of a number. So let's try running it with the number 5, which should give us the number 120. Now let's try it with another number. Great, we have completed the first example. I hope you follow along. But we're moving on to the next example where we're calculating the sum of elements in an array. Should this have not sunken, let's hope this second example does make sense to you. Here as well, we're going to start with building the main function. So we'll prompt the user to enter the size of the array to say, do you want a list of 5 numbers, list of 10 numbers, or what? And then let's declare our array which will hold this list of numbers. Now for the user to enter this element in an array, because now the user did tell us, okay, I want 5 elements in an array, but then give us these 5 elements. The first element will be a 1, the second element will be a 20, and so on. So now let's build the code to say, fill in the elements of the array. And now to display the sum of all these elements in the array. Remember, we're going to be calling a function which will be doing recursion, because the purpose of this video is to dive deep into recursion. Okay, so we're going to pass to this function this array and also the size of the array, because it's going to use just that. Might as well build this function up there. Okay, now the case of case. So now to calculate the sum of this array is, we need to move from the 5th element and then come to the 4th element, 3rd, until we get to the 1st element. Or you could start from the 1st until the 5th. Either way, but for the purpose of our code example, we're just going to start from the last element. Suppose we have 5 elements in an array. We're going to say the 5th element plus the 4th element and so on. So you see, this is the recursive case. We sum the last element with the sum of the elements in the rest of this array. Now moving on to our base case. If this array has only one element, that's when we will return that element. So we've held in now the repetition. In the termination case, you can say if the n is equals to -0, -1, or if n is less than 1. That could be a termination case. It sometimes does not become that important. And there we have it. Now let's iterate through to understand how this function works with an example. Now suppose we have an array of elements 2, 4, 6, 8, 10, which means the size of an array is 5. So the function will call the array sum. At the first iteration, when the size will be 5, we'll be calling the function sum to say 2, 4, 6, 8, 10, which has 5 elements. And since n is not 1, so we move to the recursive case, and then we will be returning that last element plus the rest of the array. And now this is the element to the rest of the array, which is the number 10 with the sum of the rest of the array. And then we move on to the second iteration, where we'll be calling where the size is now a 4 because we've reduced the size of the array. And we call the sum array 2, 4, 6, 8, and now it's on array 4, 4th index. And now we return that array element, which is number 3, plus the rest of the array. Now this is the last element of the array with the sum of the elements in the array. And now going to the third iteration where the n is 3, we call sum of array 2, 4, 6, where the size is a 3. We return the array element with index 2 plus the sum array 2, 4, and thus adding the elements of the array, this element number 6, with the sum of the elements in the rest of the array. And when we move to the 4th iteration, where we are now on the second element, we are basically calling the array which is now element 2 and 4. So here we are just returning this second array with element 1 plus the rest of the elements in the array, which is that last 2, having added the last element of the array with the sum of the elements in the rest of the array. And moving on to the 5th iteration, where our n is now equals to a 1. This is the array, meaning we only have one element. Since 1 is the base case in our condition, we return that array element. This returns only one element of the array, returning up the recursion key. Now, as we've reached the base case, the recursion starts unwinding. We start returning values back up the recursion tree and adding them up as we go. Eventually, we get the sum of all the elements in the array. 2 plus 4 plus 6 plus 8 plus a 10, and that giving us a number 30. Each iteration of the recursion involves adding the last element of the array with the sum of the elements in the rest of the array, until we reach the base case where the array has only one element. Recursion in this example allows us to solve the problem of summing elements in an array efficiently by breaking it down into simpler subproblems. And there you have it. Recursion is a very powerful concept, and it allows us to solve complex by just breaking them down into simpler, repetitive tasks. Whether you are a machine that produces a part of a product or tackling math problems, recursion is all around us. I hope you found this explanation very helpful. If you did, don't forget to like, share, and to subscribe for more educational content. Until next time, happy coding.